Section 2.7 is on parent functions and transformations. A parent function is the basic form of a particular type of function, and there are four that you need to know about. The first is the constant function. That's f of x equals a, where a is any number. The identity function, where f of x equals x. The absolute value function, where f of x equals the absolute value of x. And the quadratic function, f of x equals x squared. Here's a graph of what each of them looks like. So a constant function where y or f of x equals a number is always a horizontal line through that value on the y-axis. The identity function is the line y equals x. It is a perfectly diagonal line that goes through the origin and has a slope of positive 1. The absolute value function, as we saw in the last section, is basically a v. This one is centered at the origin, and each part has a slope. Well, the right-hand side has a slope of positive 1, and the left-hand side has a slope of negative 1. And as you'll remember from Algebra 1, a basic quadratic function, y equals x squared, is just your basic parabola with its vertex at the center. Just like we did in geometry, we can do transformations on these graphs. We can do a translation, which means we move it up, down, left, or right. A reflection, which means that we can flip it over the x or y axis. Or a dilation, which will shrink or enlarge the graph proportionally. In your text, there's this really cool chart on transformations of functions. So let's take a look at this. It looks a little confusing, but when we do some examples, it'll probably make a little more sense. The first is a translation, and that's going to be moving the graph left, right, up, or down. Now, the most confusing part of this is if you have x plus something inside the function, that's going to actually move the graph to the left. It's kind of counterintuitive. We think of plus going to the right, but it's actually to the left. And then if there's an x minus a number inside the parentheses, then it's going to move the graph to the right. So kind of the opposite direction, because we tend to think of negative to the left. If there's a number added outside the function, it's going to move the graph up. A number subtracted outside the function, it's going to move it down. A reflection, basically if there's a negative in it, it's either going to reflect it across the x-axis or across the y-axis. A dilation, whether there's a number outside the function or within the function, is going to determine whether the graph gets stretched or compressed vertically, or compressed or stretched horizontally. Basically, if a is greater than 1, you'll see that the graph is going to get a little bit narrower. And if a is less than 1 but greater than 0, it's actually going to be a little bit wider. And we'll take a look at that as we do a couple examples here. So here's our example. Describe the transformation in each function and then graph it. So here we're going to be working off of the parent function of the quadratic function y equals x squared. And so here's the basic graph, and I went ahead and did that one in black. Now let's take a look at a transformation on that where we take the x squared and we subtract 2 kind of on the end. That means that this graph is going to be I'm going to go ahead and do this in pink. This is going to be translated down 2 units. Okay, so a minus 2 kind of separate from the function itself, the function being x squared, and a minus 2 means it's going to be translated down 2 units. So I'm going to do that over here in pink. So my vertex is going to move down 2, and then I'll have these points here, and then to get to the next point I went up 3 and right 1, and the same thing over here. And then actually if you notice, they're all kind of down 2 from it, so I'll just do one there and one there. And there is my graph of y equals x squared minus 2. The parent graph has been shifted down 2 units. Is that right? Is that blue? That's good, that's blue. Okay, now we have y equals x squared plus 6. Well, if a minus 2 outside means down 2, a plus 6 out there means that it's going to be translated up 6 units. And I think I can do this all in the same graph here. So my vertex is going to move up 6 units, and then every corresponding point is also going to move up 6 units. So the function y equals x squared plus 6 is going to look like that. Let's go to our green one here. Y equals the quantity x plus 1 squared. You'll notice that the plus 1 is inside the parentheses and then the whole thing is squared. So this is going to be a translation of 1 unit to the left. And this is the one that's a little bit confusing because we see a plus 1, we would think, well, maybe it should go to the right. But actually what's going on in here is this is the same as x minus a negative 1. So your vertex now is going to be at negative 1. So all of these points on the parent graph are going to move 1 to the left. And I think my graph is getting a little confusing here, so I'll just keep it kind of small. So there's the graph of y equals the quantity x plus 1 squared. And then our last one here, y equals the quantity x minus 4 squared. That's going to be translated right 4 units. So the vertex for my parent graph is going to be over here, and every point will move over to the right 4 units. Oh, it actually intersects it right there. And that one's going to look like that. So my graph is a little messy, but hopefully you can see how changing by adding or subtracting a number outside the x squared or within the x squared moves the graph up or down, left or right. The next one I want to take a look at is these are going to be a reflection and some dilations. So let me switch back to pink. Okay, so here we have y equals negative x squared, and this is going to reflect the graph over the x-axis. So basically it's going to flip from being above the x-axis to being below the x-axis. So the vertex is going to stay the same, but every point is just kind of transferred down to here. And that's the graph y equals negative x squared. And you'll probably remember from Algebra 1 when we had a negative out in front of our quadratic, it was an upside down parabola. Okay, our second one is y equals 3x squared. And since this is a number greater than 1, it's going to be compressed. In other words, it's going to be a little bit closer to the x-axis. And I went ahead and made a table of values in my notes here, so I'll show you what that looks like. So we'll have 0, 0, and then we'll have the point 1, 3, and negative 1, 3. And then when we put 2 in there, it's going to give us a 12, which again is going to be off the graph up here. If I can do a little bit of that, and negative 2 is going to give me the same thing. So you can see how, in comparison to the parent function, the blue one, where we have the coefficient of 3 in front of the x squared, is a little bit tighter to the y-axis. It's a little more narrow. And then our last one here, y equals 1/5 x, this one's going to be expanded. And I did a few values here. Again, that's going to have 0, 0. It's going to be at the origin. And I want to pick some numbers that are going to work here. So when I put a 5 in here, 5 squared is 25, divided by 5 gives me a 5. So 2, 3, 4. So that's going to be this point here. And then I'll have the similar one when I plug in negative 5 for my x over here. And I really can't do any other points because it would just be way too far off the graph. So here you can see that having a coefficient of a number between 0 and 1 makes the graph a little bit broader, so it's a little bit wider about the y-axis. So in this video we took a look at some of the parent functions that you should be familiar with: a constant function, the identity function, the absolute value function, and the quadratic function, and how we can do transformations on those, either translations, moving them up, down, left, right, reflections over the x or y axis, and then dilations where the graphs are either expanded or compressed.